Hello friends, Mr. Burrell here. We're just in the middle of Unit 3. We've been talking about parallel lines and some of the relationships that happen with the angles formed by crossing through two parallel lines with a transversal or with another line. We've talked about some of these relationships. We've talked about how those angles are related to each other, whether they're congruent, meaning that they're the same, or they're supplementary, meaning they're adding up to 180 degrees. We've talked about some of those properties. Today, we're going to go ahead and we're going to use those properties, use those theorems, to solve some different kinds of problems associated with parallel lines. So by the end of this video, these are the things that I hope you're able to do. I hope that you're able to use the theorems that we've discussed, those different angle relationships, and I hope that you're able to use them to find missing angle measures given a set of parallel lines. I want you to be able to decide whether or not two lines are parallel based on given angle measures. We're going to talk briefly, a little bit in this video about parallelograms. That might come in a separate video, and find missing angles on parallelograms. So just as a review, I'm going to kind of color code this little graphic here with these parallel lines. So we talked in the other lesson about these different angle relationships. We talked about alternate interior angles, alternate exterior angles, consecutive interior angles, and corresponding angles. Those are some of the main ones we talked about. If you need a refresher on that, feel free to watch my previous video. But something that happens because of all those relationships, you notice here that all of these, I've kind of color-coded these, all of these red angles, 1 and 4, 5, and 8, are going to be congruent to each other. All of these blue angles are going to be congruent to each other. And then when I put a red and a blue angle together, those are going to be supplementary angles, meaning that they're going to add up to 180 degrees. So amidst all the relationships we discussed, like alternate interior angles, or alternate exterior angles, or corresponding angles, so like this one and this one, or consecutive interior angles, all those relationships that we've discussed form these congruent angles. So when in doubt, if you sometimes forget what those relationships are, you can always remember that these pairs of angles are congruent to each other. So using that information, let's take a look at these lines. Are these two lines, these ones right here, that was bad lines, but are these two lines parallel to each other? Well, no. Actually, it's pretty straightforward to see that these are not parallel to each other. If I were to kind of draw those lines, extend those lines on into the distance there, you see that eventually they do cross. Parallel lines don't cross, so these are not parallel. Looking a little bit closely, I know that from looking at the lines, but I can also determine that these lines are not parallel by looking at these angles. So for example, if I look at this angle right here and this angle right here, those are alternate interior angles. Those are alternate interior angles. And in parallel lines, those angles need to be congruent. They need to be equal to each other. They have to be the same. And you notice here, this angle is 69.27 degrees. This one is 56.61 degrees. They're not the same. So these lines are obviously not parallel, because if they were parallel, they would be the same. That's the same with some of these other angle relationships. For example, in parallel lines, consecutive interior angles, these two, would be supplementary, meaning they would add up to 180 degrees, which in this case, they do not, right? So that's what we're going to be talking about here. We're going to look at these relationships between these angles and these parallel lines to kind of solve problems like this. So in this other video, we discussed that if I have two lines that are parallel, all of these angle relationships are true. Alternate interior angles are congruent, alternate exterior angles are congruent, consecutive interior angles are supplementary, and that corresponding angles are congruent. We talked about how if two lines are parallel, all those angle relationships exist. Now we're just saying that the same thing is happening in reverse. If I know those angle measurements, so if I know any of these, then the two lines where those relationships exist are parallel. Maybe that goes without saying, but they go back and forth. If I have two parallel lines, I know that those angle relationships exist. If I know those relationship angles exist, then the two lines are parallel. So those are the theorems, those are the tools that we have like in our math tool belt to prove that two lines are parallel. If any of those things are true, any of those angle relationships, then the two lines in question are parallel. Notice that there's two other angle relationships that we discussed in the previous lesson that I haven't mentioned yet. We talked about linear pairs and vertical angles. So, riddle me this. So this first question says, if I know 1 and 2 are a linear pair, remember that a linear pair is two angles that form a straight line, so this line right here. So if I know that those two are a linear pair and that they're supplementary, adding up to 180 degrees, is that enough to know that these two lines are parallel? That's true that these two are supplementary, that they're a linear pair, but is that enough to say that these two lines are parallel? Well, let me just draw, like if this is my transversal, let me just draw like another line here. Are those two lines parallel? No. Because notice that a linear pair only referred to this section up here. It didn't tell me anything about the relationship between this line. See? It only told me about the relationship between this section of lines up here. Same goes for this statement. If I know that 1 and 4 are vertical angles, so vertical angles are angles that are directly across from each other, yes? And those angles are congruent. Is that enough to say that those two lines are parallel? Well, again, it doesn't matter if there's these relationships up here don't affect this line down here at all. So I can write this line however I want to, and it can still not be parallel to this one up here. In order to prove these two lines are parallel, I'm going to need to have one up here and one down here. So like, for example, if I knew that these two angles were congruent, those are alternate interior angles. I have an angle in this section, an angle in this section. That's enough to prove that those lines are parallel. Okay. Let's go here. So it says, based on the above, those theorems that we just discussed, list 4 ways you could show the two lines in the figure are parallel. So I could say, okay, well, angle E and angle D are congruent. So angle E is congruent to angle D, and they are alternate, I'm going to abbreviate this, alternate interior angles. This is the symbol for an angle. So since alternate interior angles are congruent, they're the same, that's enough to show that these two lines are parallel. I could also say angle H is congruent to angle D, angle H is congruent to angle D, and those are corresponding angles. And since those corresponding angles are congruent, that's enough to show that those two lines are parallel. Let's see, I could also say that angle H is congruent to angle A. So angle H is congruent to angle A because those are alternate exterior angles. And when alternate exterior angles are the same, when they're congruent, that's enough to prove that those two lines are parallel. The last one I could use is, say I know that angle F and angle D. So the measure of angle F added with the measure of angle D, that's what these little M's mean, is measure. I know that those are consecutive interior angles, and if they add up to 180 degrees, or they're supplementary angles, consecutive interior, that's enough to prove that these two angles are congruent, or these two lines are parallel. And indeed, 62 plus 118 does indeed equal 180 degrees, so that's enough to show that these two lines are parallel. Okay. So again, I don't want to beat a dead horse, but just so we can make sure we're on the same page, in the figure below, angle 1 is equal to 80 degrees. So this angle right here is 80 degrees. And notice, based on that color coding that I showed you at the beginning of this lesson, that all of these angles right here are all going to be 80 degrees. And all of these angles right here are going to be supplementary to those angles. Okay? So notice here, measure of angle 1 is 80 degrees. So what's the measure of angle 2? Well, these are a linear pair. Angle 1 and angle 2 are a linear pair. So that means they have to add up to 180 degrees. So the measure of angle 2 is going to be 100 degrees. Measure of angle 3, that's going to be 80 degrees. Let me change my color again. Measure of angle 3 is going to be 80 degrees. Because of a couple reasons. You could say 1 and 3 are vertical angles. They're directly across from each other. I know vertical angles are congruent. Let's go back to red. Angle 4 Angle 1 and angle 4, again, are a linear pair, so they are going to add up to 180 degrees. If I take a look over at angle 5, notice that angle 5, let me get this going, angle 5 and angle 1 are corresponding angles. So since they are corresponding angles, and these lines are parallel, that they are going to be the same measure. And then the measure of angle 6 is going to be 100 degrees because angle 5 and angle 6 here are a linear pair. It's not the only way that I could prove all of those things. But I want to drill this into you, how you can find the measure of all these different angles in parallel lines based on these relationships that we've talked about. Okay. So this section says, mark the statements that guarantee lines M and N are parallel. So, for example, if the measure of angle 4 is 64 degrees and the measure of angle 5 is 64 degrees, is that enough to prove these lines are parallel? Well, what kind of angles are these? These are consecutive interior angles, consecutive interior angles. Well, consecutive interior angles are supposed to be supplementary, or they're supposed to add up to 180 degrees. Does 64 and 64 add up to 100 degrees? 180 degrees, sorry? No. They do not. So that does not tell me that those lines are parallel. Those lines are not parallel if those two angles are both 64 degrees. Let's take a look at measure of angle 3 and the measure of angle 6. If the measure of angle 3 is 118 degrees and the measure of angle 6 is 62 degrees, is that enough to prove those lines are parallel? Well, those are consecutive interior angles again. So those are consecutive interior angles, meaning they have to add up to 180 degrees if those lines are parallel. Well, 118 plus 62 is indeed 180 degrees. So yeah, that information is enough to tell me that these two lines are parallel. Well, what about the measure of angle 1 and the measure of angle 5? What if they're both 42 degrees? Well, those are corresponding angles. And what do I know about corresponding angles and parallel lines? They are congruent, meaning that they are the same. And since 42 does indeed equal 42, since those are indeed the same, yes, that information is enough to prove to me that those two lines are parallel. Okay. You can do that little section on your own if you wanted to take a look at that for a little bit of a challenge. So this last part we're going to talk about, it says find the value for x that makes the lines parallel. So in here, instead of just having numbers, now I have like an expression. I have an equation here. So I have 2x here, and then I have 120 degrees right here in this angle right here. So it says find the value for x that makes the lines parallel. Well, let's look at these two these two angles, sorry. If these lines were to be parallel, these are alternate interior angles right here and here, which means that for these lines to be parallel, those angles would have to be equal to each other, or they would have to be the same. So 2x would have to be equal to 120 degrees. Well, notice here, now I have an equation to be solved. If I have 2 times x equals 120, how do I solve for x? Well, I divide by 2. Which gives me x equals 60. So when x is equal to 60, that's the value of x that would make these two lines parallel to each other. That's what would make those alternate interior angles congruent. Okay? Feel right about that? Okay, let's move on to this next little section. So again, it says find the values of x and y that will make the lines parallel. So I have y's here. These angles right here have y's in them. And then let me switch colors. These angles over here have x's in them. So I'm going to set both of these equations up. So let's look at my x's, the equations that have x's in them. Well, what do I call these angles? The blue ones, those are alternate exterior angles. And alternate exterior angles, if these are parallel lines, need to be congruent. Alternate exterior angles need to be congruent. Which means that those measures, 17x minus 70, that has to be equal to 2x plus 5. Okay? Those have to be equal to each other. So now again, I've set up an equation that I can solve. I'm going to go ahead and get all my x's on one side, which gives me 15x minus 70 equals 5. I'm going to add 70 on both sides, which gives me 15x equals 75. And then when I divide by 15 on both sides, I get 15, 30, 45, 60. X equals 5. So when x is equal to 5, that will make both of those angles congruent. Let's double check. If I do 17 times 5 minus 70, 17 times 5 is 85, minus 70 is equal to 15. And then over here, if I put 5 in for x, that's 2 times 5 plus 5, which is 10 plus 5, which is 15. So indeed, they are the same. Okay? Let me erase some of this jazz. What about the y's? What about the y's? Let's take a look at my y angles. I'm going to change colors here. So these two angles, those are called consecutive interior angles. And consecutive interior angles, they need to add up to equal 180 degrees. So I have this angle, 3y plus 5, and that angle added with this angle, 5y plus 15, those better add up and equal 180 degrees. See what I'm doing here? So now, let's see here. 3y plus 5y, I can combine those together to get 8y. 5 plus 15, I can combine together to give me 20. I get 8y equals 20, or sorry, 8y plus 20 equals 180. And then I can solve for y. I would subtract 20 on both sides, which gives me 8y equals 160. Divide by 8 on both sides, which would give me y equals 20. And I'll let you plug those back in to double check that they work, but indeed, if I were to plug 20 in for y in both of these cases, I better get two angles that add up to 180 degrees. So those are the kind of problems you will see on your homework assignment. So we're going to skip some of those parallelogram problems for a minute. So a couple Christmases ago, I want to show you just like where we use parallel lines in the real world. Parallel lines pop up all over the place, but I helped my brother-in-law with a problem a couple Christmases ago. My wife really likes to paint, and her brother, wanted to build her a large easel to paint canvases on. So like she puts canvases on here and like kind of tightens them into place, and then she can stand up or like sit on a high stool and she can paint on there. So he wanted it to be symmetric, meaning that that the right hand side was exactly the same as the left hand side. So he wanted it to as if you could fold it in half, it would be the same. And these horizontal slats right here. These horizontal slats right here needed to be parallel, because in order to cinch the canvas in there, they would need to be exactly parallel. So the cuts that he made needed to be pretty exact in order to secure it the way he wanted to. All those cuts need to be pretty precise in order to make everything fit the way that he needed to, so it would secure these canvases, So he came to me with this problem, and he was like, Mr. Burrell, what do I do? How do I determine how I need to make all these cuts? So I said, well, how big do you want this to be? At how much of an angle do you want these slats to be? He said, well, I'm thinking I don't want it to be exactly at a 90-degree angle. I kind of want it to be at a slight slant. So we decided on the angle of 82 degrees. This angle right here was 82 degrees. So I said, well, bro, if that's 82 degrees, that means this angle is going to be 82 degrees. And this angle is going to be 82 degrees, and this angle is going to be 82 degrees, and this angle, and then on the other side, if he wanted this to be 82 degrees, so would all of these angles. So he was like, oh, so all of these cuts, I just have to make it this same angle measure, and then everything should work out fine, right? And I said, yes, because of these properties I know about parallel lines. If I wanted these lines to be parallel, all of these, these consecutive interior, or these alternate interior angles, would have to be congruent in order to make that work. He also recognized that on the other side, these angles right here would be about 98 degrees. And then all of those angles in these different sections would also be the same. But it was really cool. I really had a lot of fun helping him with this project. He was out there with like a protractor and with his angle saw, or like his table saw, making all these different angle measurements. And he had a lot of fun. I had a lot of fun. I think this is a really good example of where we use math in the real world. So I want to just give you that as an example of where we use parallel lines. So hopefully now you're able to use the theorems that we discussed from Concept 1 to find missing angle measures in parallel lines, and then decide whether or not two lines are parallel based on given angle measures and different equations. We will discuss parallelograms in another time. But I hope that was helpful. Please don't hesitate to reach out to me if you have any questions whatsoever, if there's anything I can help you with. And I hope that you enjoyed that as much as I did.